So let's look at the next one in section 3. It's the 2005. They give you the graph of f, and they say in part A, let g be the function g of x negative 4 to x f of t. For each of g of negative 1, g prime of negative 1, and g double prime, find the value or state that it exists. So g of negative 1 equal negative 4 to negative 1 of f of t. You don't have a function rule, so you're going to do geometric shapes. I did a triangle and a rectangle. You could have done a trapezoid, but my triangle was negative 1/2 because it's below the x-axis, 1 and 3. And then my rectangle was negative 3 times 2 because it was under the x-axis, and you get negative 15/2. Now, g prime of 1, remember when you take the derivative of an integral, it'll just be f. So graph of f is the derivative of g. So g of negative 1 will just be negative 2. And g prime of negative 1 doesn't exist because if you look, this slope is different from this slope. So you can't take the second derivative. It doesn't exist. So part B says for the function g defined in part A, find the x-coordinate of each point of inflection of the graph of g on the open interval. Explain your reason. So a point of inflection is going to be where the derivative changes direction. And remember, f is the derivative of g, so it's going to be at x equal 1 because g prime, which is f of x, changes from increasing to decreasing. Now part C says let h be the function h of x, the integral x to 3 of f of t. Find all values between negative 4 and 3, which h of x equals 0. All right, so you kind of got to look at the shapes. So you know h of x is x to 3, but we're going to do a negative in front of it to get them in the right order. But we evaluate the integral by shapes. So if you look at x equal negative 1, go right here at negative 1 to 3. So let's say we were going negative 1 to 3. So we would write it this way. That's going to be that little triangle, this big triangle, and that triangle. They negate each other and equal 0 because this and this plus those two equals 0. And you could write it out and solve it, or you can just visually look at it. Now, where else do they negate each other? They negate each other from 1 to 3, because from 1 to 3, it would be this half triangle and this half triangle, so they would negate each other. And then 3 to 3, by integral rules, that always equals 0. So it's x equal negative 1, x equal 1, and x equal 3. Now part D, it says for the function h, find all intervals for which h is decreasing. Okay, so think about this. H of x is negative 3 to x of f of t. But, it originally was x to 3, but we had to put a negative in front of it. So h is going to be decreasing normally where the derivative of h would be negative. But since you've got a negative in front of it, it's going to be the opposite. So it's going to be where f of x is positive. We'll say that again. Normally, the derivative of h would tell you where it's decreasing, where the derivative is negative. But because we had to put a negative sign out front to switch the integrals, it's going to be where h, the derivative of h, which is f, is positive. So it's positive from 0 to 2. So that's going to be your answer. So the next one in that section is 2004. They give you the graph of f, and they tell you g of x is negative 3 to x of f. And it's to find g of o and the derivative of g of o, or 0. So g of 0 is going to be negative 3 to 0 of f of t, and we are going to use shapes. So if we go negative 3, we can do the trapezoid right here, the whole trapezoid, which would be 1/2, 3, 2 plus 1, because this side is 1, this side is 2, and it's the width of it is 3, because you're going from -3 to 0. So you get 4.5. Now g prime is 0. Remember, the graph of f is the derivative of g, so 0 is paired with 1. Now part B says find all the values between -5 and 4 which g attains a relative maximum. Okay, remember the graph of f is the derivative of g, and it's going to be a max where it changes from positive to negative, and it changes from positive to negative at x equals 3. And your reasoning again is g prime of x equal f of x, and it changes from positive to negative at this point. C says find the absolute minimum value, -5 and 4. Remember, when you see the absolute, you're going to use the endpoints, and you're also going to where it would be a minimum. And it's going to be a minimum where it changes from negative to positive, which is going to be at -4. So we're going to try g of -5, g of 4, and g of -4. So you're going to put that in, and you're going to use this function. So -3 to 4, we have to put a subtraction or negative sign out front to switch the order of the integrals. And then we're going to use our geometric shapes, and you get -1. Now g of 5, -3 to 5. Oh, sorry, this is -5. So -3 to -5, we're going to put a negative sign and switch the integrals. And again, we're going to do our geometric shapes, and you get 0. So again, let's look at g of 4. So you're going to go from -3 to 4. You don't have to switch the integral because it's the right order. Now we know g of 0, because we found that up there, is 4.5, and we're going to go from 0 to 4. Well, look, 0 to 4, this little triangle and this little triangle negate each other out. So we're really going from 0 to 2. But it's just these little corners. So what you got to do is you got to do the rectangle minus out the semicircle. So the rectangle is 2 times 1 minus 1/2 pi 1. So you're going to get 13 minus pi over 2. So the absolute minimum is going to be the -1, which was at g of -4. And part D says find all the values x in the open interval at which the graph of g has a point of inflection. Remember, again, the graph of f is the derivative of g. It's going to have a point of inflection where it changes direction. So x equal -3 because it changes from increasing to decreasing. X equal 1 because it changes from decreasing to increasing. And x equal 2 because it changes from increasing to decreasing. The next one in this section is the 2004. They give you the graph of the derivative f, and it has horizontal tangents x equal 1, x equal 3, and it's twice differentiable, and it tells you starting point, f of 2 equals 6. It says find the x-coordinate of each point of inflection of the graph of f. Well, this is the derivative. Remember, point of inflection is where it's going to be changing direction. So x equal 1 because f prime changes from increasing to decreasing, and x equal 3 because f prime changes from decreasing to increasing. Part B, at what value does it attain its absolute minimum value? Show the work that leads to your answer. Remember, absolute, you're going to use your endpoints, and where it could possibly be a minimum. It's going to be a minimum where it changes from negative to positive, which would be 4. So we are going to check our endpoints, and which our endpoints are -1 and 4, 5, and our possible place where it changes from negative to positive is 4. So if you set up your integrals, you're going to start with your starting point, f of 2, 2 to the -1. When I show you the work, we're going to have to switch the order there. F of 2 from 2 to 5, f of 2 from 2 to 4. So if we come over here to do, we have to change the order on this one. This is the endpoint f of -1. So we switch the order, and then we're going to do our geometric shapes. We start with our starting point, and then we're going to minus, and then this is below the x-axis. and this one's below the x-axis. So you're going from -1 to 2. So you're kind of roughly making a triangle and a triangle there. So they're both underneath the x-axis. So you get approximately 10. These aren't exactly triangles, but you're going to make it as best you can. So f of 5 is f of 2 plus 2 to 5. So you're doing, I basically did a rough looking triangle from 1 to 3. So that makes it -1/2, width of 2 and 2. And then I did this little triangle, which would be -1/2, 1 and 2. And then this one I made a rough triangle, which would be 1/2, 1 and 2. It's not going to be exact, but it's approximately going to be 4. And then f of 4, you're going from 2 to 4, and you're going to do 6. And again, I would use the same triangle, so you get -2 and -1 just from these figures up here. So you get 3. So the absolute minimum is this. C says, let g be the function g of x equal x times x of x, x times f of x. Find an equation for the line tangent to the graph of g at x equal 2. So remember, when you got a tangent line, you've got to get an order pair and a derivative. So g of 2 equal 2 times f of 2. And we know f of 2 is 6, so 2 times 6 is 12. So we have an order pair. G prime of 2, we're going to have to do product rule. So we're going to do the derivative of x is 1 times f of x plus x times the derivative of f of x. So f of 2 plus 2 times f prime of 2 will be 6 plus 2 times -1. So that came from the graph because it's f prime. This they gave us. And so we get 4. And then we plug our order pairs in and get our tangent line.